So today we're stepping back into the P chapter for a brief run-through on solving inequalities. Now I'm not going to go all the way back and explain every little detail. Primarily I'm just going to explain it in the context of solving inequalities. So if you need additional instruction, then we can talk about that in the Math Center, or you can look also in the P2 section of your book. There's a more detailed explanation. But I just wanted to do a quick run through of just reading these inequalities. So each one of these reads a little bit different. This one says x is less than 2. So it's either less than or greater than, and then it's whether it's the equal is set or not is whether or not this extra line is here. So just a reminder that the larger number is always on the mouth of it. So basically the 2 means it should be bigger. So the way that I just want to show a graph of what this would look like. X is less than 2. So we just have our number line. We don't have x and y, so we just have basically our x's here. So here is 0 in the center, and so we're looking at 2. So x is less than 2 looks like the solutions are, so 2 is not included in this. So I use an open circle to say 2 actually isn't, I'm not allowed to use 2 as a solution in this. And then all numbers that are smaller than 2 are in this direction. So if I wanted to graph it on the number line, it would look like this. Okay. All right, so the next one is red. X is greater than 2. Okay. And so again, I'm going to draw my picture. 0 here, 2 here. So again, 2 is not included because it does not include the extra line underneath that says that it would be equal. So I have an open circle on the 2, and then I'm looking for all numbers that are bigger than 2. So that would be to the right of 2. Now these 2 on the bottom here are very similar to the 2 on the top. This one here is read as x is less than or equal to 2. So this time, I draw my same picture. Here's my 0, here's my 2. This time, when I'm looking at 2, 2 is a solution to this particular one. Here, I'm making them a little off here, but so this time I'm going to fill in my 2. Graphically, that means the 2 is included. So now I want the 2 and everything smaller than 2. Right? So these 2 here, right, look very similar to each other. The difference is, though, here the 2 is included, here the 2 is not. And the same goes with this graph here. It'll look very much like this one here. These 2 should look alike. The only difference is this one is read x is greater than or equal to 2, so that means the equal to 2 is also allowed, and so that's the difference. So these 2 and these 2 are very similar. The only difference is when I have this extra equal sign, then that actually means that I can include the 2. Now most students can tell me that when I'm solving an inequality, basically I just treat the inequality just like it were an equal sign. So as long as I'm doing things fairly, I mean I'm adding the same thing to both sides, I'm dividing by the same thing, for the most part it works, except there's a couple of cases, okay? And that is division by a negative number or multiplication by a negative number. So I'm just going to, this doesn't constitute proof by any way, but I want to just show you why some of this works. Okay, so let me just start with an inequality that does work. So I have 4 is greater than 2. So let me add a positive number to both sides. Let's say I'm going to add 2 to both sides. If I add 2 to 4, I get 6 is greater than 2 plus 2 is 4. This is still true. Okay, so let me move to this. So this I added 2 here. I added 2. So let me instead add a negative number to both sides. So let me, or I can think of it as subtracting 3 from both sides. It's like I'm adding negative 3 or subtracting 3 from both sides. So in that case, I'm going to get 3 is greater than 1. This is still a true statement. So I'm just trying to illustrate that I can add and subtract whatever I want from both sides. Then this inequality will hold. Right? If I have a number that's bigger than another number, then as long as I'm adding or subtracting the same number from both sides, that inequality is going to hold true. Right? So the same kind of goes with multiplication as long as I'm in the positive. So let me start with my 4 is greater than 2. So let's multiply both sides by a positive number. So I'm going to multiply this side by 3 and this side by 3. So then I get 12 is greater than 6. This is still true. Let me multiply by, let's see, how about if I multiply by a half? So let's multiply by a fraction. Again, I get 6 is greater than 3. This is still true. Right, so far multiplication hasn't been an issue. However, let's multiply now by -2. Then I get -12 and -6. And now if I try to put my inequality symbol in here, my inequality doesn't hold anymore because actually -12 is smaller than -6. So this is why we end up switching the sign. So really this should read -12 is less than -6. So when I'm multiplying by a negative number, and it also happens when I divide by a negative number as well, I need to change the direction of my sign. Now in a lot of cases I can actually avoid dividing by a negative number. So let me just walk into our first example here. All right, so we're just going to kind of run through all the different types of equations that we solved right now, only this time we have inequalities. All right, so one way that I could solve this, all right, so I have this inequality here. As long as I'm adding, subtracting, or multiplying by a positive number, or dividing by a positive number, then I treat this just like that inequality symbol was an equal sign. So let me subtract 2x from both sides. When I do that, I end up with -5, the inequality symbol still here, greater than, then I get x plus 7. So now I want to get x alone, so I'm going to subtract 7 from both sides, and I end up with -12 is greater than x. Now typically we like to write it the other way, so I'm going to write this as x is less than -12. Right? The inequality symbol, I've got it going the opposite way, but I've written it backwards too. So since the small tip is facing the x, I've got the same thing here. So this is read x is less than -12. Now I could have done it another way, right? There's multiple ways that you can go about solving equations. So what if I had 2x minus 5 is greater than 3x plus 7, but this time maybe I really like to keep my x's on the left hand side, so this time I can subtract 3x from both sides. So now I have -x minus 5 is greater than 7, and I add 5 to both sides and I get -x is greater than 12, right? I'm adding 5 here and I'm adding 5 here. Now I don't have x alone. I need to really divide by -1. And now this is a case where in order, you see, I'm going to have to flip my sign to make it match. X is, since I divided by a negative number, 12 divided by -1 is -12, but I need to flip my sign. So here and here I get the same exact answer. Here I managed it without dividing because I kept my x's positive, and here to get the same answer because I didn't move my x's to the positive side, I end up with this value. So it's only when I'm dividing by a negative number or I'm multiplying by a negative number that this happens.